Good afternoon. This is Alicia, and this is our live lecture for week 2. And this is the first part of that. We had some issues recording yesterday, and so I am re recording it so that you can watch it. So, here are some things that I want to be sure that you're doing. Excuse me. I want to make sure that you're spending time inside Mobius. Okay. You want to start reading your assignments early in the week, and you want to continue working on them every day. You want to make sure that you are completing those assignments on time. You don't want to get behind. It's hard to catch up once you get behind. And then I want you to make sure that you're asking questions when you get stuck. There's a general questions discussion board in your class. You can ask questions there. You can email your instructor. My advice when you email your instructor is to include pictures. Include a picture of the problem on the screen from Mobius and include a picture of your work. That is the best way that you can really get some good information from your teacher, and you can get it quickly when you do that. And your other option for asking questions and getting some answers is through tutoring. And the way that you access your tutoring, you've got to be inside Brightspace and inside your math class. Okay. So you're inside Brightspace and you are inside your math class. Then I want you to go to where it says course menu and click on learning modules. At the bottom of learning modules, you'll see something called academic support. Okay. And once you click on academic support, the place that you're going is get help with my schoolwork. That is where you are headed. That's where you want to go. Okay. We are going to spend most of today on factoring because factoring tends to be the area that students struggle with the most. And having a good foundation in factoring makes you successful in all of the other things that you need to do for this particular unit. So most of our time today is going to be spent on factoring. So before we do that, I want you to think about these 3 words. Okay. I want you to think about these 3 words. I want you to think about what something you solve looks like, what something you simplify looks like, and what something you factor looks like. Okay. Now I have kept the notes up from yesterday just to save a little bit of time so we can make sure we get to do lots and lots of problems. Okay. When I am solving something, I'm really looking at an equation or an inequality. To solve, I have to have an equal sign or an inequality sign. We are solving an equation. We have an unknown variable and we are finding the value of that unknown variable. So when I am solving something, I am finding the unknown variable. Okay, I'm finding that. The next thing that I want to talk about is simplify. And we're going to do a few examples of simplifying today. But I want you to think about simplifying as putting everything together. Simplifying means we're putting it together. We're adding, we're subtracting, we're multiplying. Okay, we're getting rid of those parentheses as much as we can. We're combining like terms. There is no equal sign when we are simplifying. There's no equal sign. Those variables are going to be part of our answer. Okay, we are putting everything together and trying to get it to its simplest form. Okay, combining like terms is a big part of simplifying. At its most basic level, we're looking at fractions. 4/8, we're simplifying it to 1/2. Okay, simplifying is putting everything together. Now, factoring, when we do factoring, we are breaking things apart. We break things apart when we're factoring. Think of it as working backwards from simplifying. Very often your answer looks like the original problem did when you were trying to simplify. Okay? So factoring we are breaking things back apart until their original form. And that's often done so that we can solve an equation. But I do want us to understand the difference between solve, simplify, and factor. Okay? We will start simplifying and then we'll move to factoring a little bit later. Okay. This is a situation where we were simplifying yesterday. What I have is I have two trinomials together, and I'm putting them together. I am adding those. So I have 3x to the third plus 7x squared minus x plus negative 3x squared plus x plus 7. Okay? Before you can get rid of your parentheses, you want to ask yourself if there's anything inside those parentheses that can be combined. Then you want to ask yourself, does anything need to be distributed? Now, in this situation right here, we've got a plus sign. On your homework, you may see a minus sign right there. And if you see a subtraction sign right there, you need to distribute that negative sign to everything. Okay? You need to distribute. If you've got a minus sign right here, you've got to distribute that negative sign to everything. Okay? So these are two super important questions that you are going to ask when you are simplifying. Can anything be combined inside the parentheses? And does anything need to be distributed? Remember that like terms are your same variable raised to the same power. That's what a like term is. Okay. Another part of simplifying is when we have to FOIL, and we use FOIL a lot. So just a quick reminder on what FOIL is. FOIL is first, outer, inner, and last. FOIL is just one of those things that students tend to always remember from high school. We remember how to FOIL, okay? With first, we multiply our first terms together. Our outer, we multiply our outer terms together. Then we have our inner terms and we have our last terms. Okay, and I didn't redo these from yesterday just because these two are things that we tend to really remember. Okay, now I'm going to start reworking the problems from yesterday just to make sure that we've got it all. This problem that we're doing right now is not a FOIL situation. This problem right here is not a FOIL situation because it is a binomial, and that means you've got two terms, and that is being multiplied times a trinomial. So we have a binomial times a trinomial. So what we have to do here is we have to distribute twice. We have to distribute twice. So the first thing I'm going to do is I'm going to take 7k, and I am distributing 7k to everything in the trinomial. Okay, that's what I'm doing first. Then I'm going to take minus 5, and I'm going to distribute again. Okay, it's not FOIL, but it's very similar to FOIL because we are distributing everything to all parts of the trinomial. Okay, so let's get started. So the first thing I'm going to do is I'm going to have 7k, and I'm going to multiply that times 7k squared. Okay, then I have 7k, and I'm going to multiply that times 5k. Okay, then I have 7k, and I'm going to multiply that times negative 1. Okay, now I know when you do this that you may go ahead and multiply it as you're doing it. I tend to not do it that way. I just want you to see exactly what's happening, exactly what we're doing right there. Okay, now I'm going to take my negative 5 and I'm going to distribute it. So I've got negative 5 times 7k squared. Then I've got negative 5 times 5k. Then I have -5 times -1. And I am always one that writes too big. So I'm sorry about that. Okay. Now I'm going to simplify. So 7k, I'm going to do my multiplication. 7k times 7k squared gives me 49, k to the third. Okay, we talked about exponent rules last week. So k times k squared is k to the third. 7k times 5k is 35k squared. 7k times -1 is -7k. And remember, you can write that as -7k or plus -7k. Either way is completely fine. Okay, now we're moving into our red. -5 times 7k squared is -35k squared. -5 times 5k is -25k. And -5 times -1 is +5. Okay. Now, I'm still not finished with this problem yet because I need to combine like terms. So I'm going to start with the term that has the highest exponent. So I have 49k to the third. I'm going to look and see if there's any other terms that have a k to the third power. And if they are, then I'm going to combine those. We do not have anything that has a k to the third power. We have lots of k squared, or we have 2k squared, and then we have some k, but we don't have anything k to the third power. Okay, so next I'm going to look at 35k squared. I actually have a -35k squared. Positive 35k squared and -35k squared, they give me 0. Okay, now in your final answer, you are likely not going to write that 0 right there. You could, it's not wrong to write the 0 there. There's just no reason to. I would encourage you not to write the 0 in your final answer. Then I have -7k and -25k. Okay, so that gives me -32k. And then I've got +5. Okay, so my final answer is 49k to the third minus 32k plus 5. Okay, so what we've done right there is we have simplified this. This is one of the more complex simplifying ones. Okay, we've multiplied a binomial times a trinomial. But all of these examples right here are simplifying. Okay, you can have a trinomial plus a trinomial. You can have a FOIL situation, or where you're multiplying a binomial times a trinomial. All of these are simplifying. We are putting things together. We're trying to break or get them into their simplest form, where everything that needs to be combined is combined. What we're going to spend the rest of the class on is discussing factoring. Factoring is where we break things apart, and it is a huge component in all algebra classes. We have to be able to factor to be successful in many of our classes. Okay, so I want to focus on that really for the next bit of our time together. Okay, so there are 4 different ways to think about factoring. And this is kind of the order that I would encourage you to start with. And go through each problem and say, okay, can I factor by GCF? Can I factor by grouping? Is it a special product? Okay, these are the things that I want you to think about. And these are the most important concepts and processes of factoring. One of the things that we very often forget to do is we forget to see if something has a GCF. Okay, GCF is a greatest common factor. Okay, greatest common factor. And that is having a value, whether it's variables or numbers, that can be factored out of all of these. That's what I'm looking for. Is there a value in variables that can be factored out of all of these? Some students like to think about it as the opposite of the distributive property, okay, because we're pulling things out. Is there something common to both? I would always look at your number first, okay, and don't forget that's a negative 10. So is there a number that can come out of 5 and negative 10? And I hope you're thinking, yes, there is. A 5 can come out of both of those. Okay? A 5 can come out of both of those. Then I want you to look and say, okay, here I have x squared and here I have x. Is there something in relation to x that can come out of both of those? And yes, I can pull an x out of both of those. So I'm trying to figure out what is common. What is common to 5x squared y and what is common to negative 10xy. Okay, and the last thing that we look at is our y. So I have a y here and I have a y here. So a y can come out of both of those. So my greatest common factor for this polynomial right here is 5xy. So I am pulling that 5xy out. Now what I've got to do is I've got to look at this 5xy and say, okay, 5xy times what is going to give me 5x squared y? Then I've got to say 5xy times what is going to give me minus 10xy. And again, you want to break this down by the numbers. Okay, you want to do numbers first, then you want to do variables. So I'm going to say 5 times what gives me 5. Okay, and that's just 5 times 1. So I don't have to write that 1 down. I certainly could write it down, but I don't have to. So 5 times 1 gives me 5. Okay, now I'm going to look at my x. X times what gives me x squared? Now I hope you're thinking x. Okay, then I'm going to say y times what gives me y. And it's 1. And so again, I don't write that down. So I have 5xy times x, and that gives me 5x squared. And that is true. That is true. So I have factored out the 5xy from that first term. Now I'm going to do the same thing again. 5 times what gives me minus 10? 5 times what gives me minus 10? And the answer to that is minus 2. 5 times negative 2 gives me negative 10. Then I look at my x, and I would just have x times 1, and we don't have to write that 1 down. And then y times 1, and we don't write that down. So after I have factored this using the GCF principle, okay, I have 5xy times x minus 2. And that x minus 2 does have to be in parentheses. So what we have done is we have factored out the greatest common factor. Okay. The next part that we're going to use is we're going to factor by grouping. Factor by grouping. Okay, so the first thing that I'm going to do is I am going to look at my first 2 terms. I'm going to look at my first 2 terms and I'm going to say, is there anything common to my first two terms? Okay, that's the question that I'm asking myself. So I'm going to look at my numbers. I have a 6 and I have a 3. So hopefully you're thinking that a 3 can come out of both of those. Okay, 3 goes into 6 and 3 goes into 3. Then I'm looking at my n to the third and my n squared. Can I pull some n's out? And the answer to that is yes, I can pull out an n squared. So 3n squared times 2n is what gives me 6n to the third. Okay, 3n squared times 2n gives me 6n to the third. Then 3n squared plus 1 is what gives me 3n squared. So that's important to see right there, is that I'm only multiplying that by 1. I have pulled out the whole 3n squared. Now, be careful. You don't want to put a 0 there, because 3n squared times 0 is 0. You've got to put your 1 right there. Okay, the next thing, anytime that you are factoring by grouping, or when we start looking at trinomials with a value other than 1 in the front, if you've got a negative right here, if your third term is negative, you are always going to factor out a negative number. So I'm going to say that again. I'm looking at my second two terms, and if that third term is a negative, okay, so I've got minus 8n. If that third term is a negative, you are always going to factor out a negative. So instead of just taking 4 out of my second set of terms, I'm taking a negative 4. And when I take that negative 4 times 2n is negative 8n, and negative 4 times 1 is negative 4. These have to match. If they don't match, it doesn't work. You can't do it. They have to match. And then you've got 3n squared minus 4 and 2n plus 1. Okay? So that is factoring by grouping. Factoring by grouping. Students tend to do okay with factoring by grouping. I do want to say the only time that you can factor by grouping, you must have 4 terms. If you've got 3 terms or you've got 5 terms, it doesn't work. So you must have 4 terms to factor by grouping. Now, we will learn in a second how to turn a 3-term or a trinomial into 4 terms. Okay, so we will look at that. But to be able to factor by grouping, you have to have 4 terms. Okay, so on this page, we looked at factoring by GCF and factoring by grouping. Now, before we get into the big factoring trinomials, I want to talk a little bit about special products. Okay, so here is an example of a special product. I have 25x squared minus 121. Now, I wrote down perfect squares last week, but I want to remind you what perfect squares are. 1 squared is 1. 1 is a perfect square, and if I take the square root of 1, I get 1. Okay, let's look at 4 squared. 4 squared is 16. 16 is the perfect square. And if I take the square root of 16, I get 4. 81 is a perfect square. And if I take the square root of 81, I get 9. So these over here are your perfect squares. They are all your perfect squares. And when I take the square root of those, that is when I get this number on the left. So I want you to realize too that x squared is perfect. The square root of x squared is just x. We also forget x to the fourth. X to the fourth is also perfect. Okay? The square root of x to the fourth is x squared. So that's one of the things that you might want to write down in your notes. Okay. So here I have 25x squared minus 121. So I hope that you're realizing that 25x squared is perfect. And I can take the square root of 25. And that gives me 5. The square root of x squared is x. Okay, so all I've done is I have taken the square root of this right here and written it down in both of my parentheses sets. Okay, now what I'm going to do is I'm going to take the square root of 121. That is not one that we remember. Sometimes we have to think about that. So the square root of 121 is 11. So I am going to put 11 on each side of this. Okay, now the special product, the difference of perfect squares, factors to your square root of your first term plus the square root of your second term times the square root of your first term minus the square root of your second term. Okay, so I have a squared minus b squared, and that factors to a plus b and a minus b. Now, there's a couple things that I want you to realize. This right here must be a perfect square. If it's not perfect, it doesn't work. Okay? This right here must be perfect. If it's not a perfect square, it doesn't work. This must be subtraction. If it's addition, it doesn't work. It must be subtraction. Now, I want to talk about why that is. Why that has to be subtraction. Because students all the time want to make that a plus and use the same property, and you can't. It doesn't work. If I were to FOIL this back out, and I said 5x times 5x is 25x squared. 5x times negative 11x is negative 55. I'm sorry, negative 55x. 11 times 5x is positive 55x. And that right there is the important piece to this special product. You can do 11 times negative 11 and get negative 121. So the reason that this factors is because this right here cancels out. That cancels out. Okay, so I end up with 25x squared minus 121 because those cancel out. And remember, factoring is us working backwards. Okay, factoring is us working backwards. This right here is just to check it so that you can see why it works. This is our answer. I have factored that, but I want you to remember when I am factoring, I am working backwards. So if I need to check it, I can multiply those things together and I can see that it works. Okay. We're doing well on time here, so I'm glad. Okay. Trinomials. This is definitely the area that we factor the most. We factor trinomials the most of any other polynomial. Okay. Factoring trinomials is likely something that you remember. So what I have over here on the right, I have a trinomial written in standard form, okay? And the number in front of my x squared is a 1. And you factor it differently based on what's in front of that x squared. And trinomial just means 3 terms. So standard form of a trinomial with a value of 1 in front of the x squared, that's my a equal 1, is x squared plus bx plus c. That number at the end is going to be what we call our product, and that b value is going to be what we call our sum. Okay, so here I've got my first one that I'm looking at. I identify my 6 as my product. 6 is my product. Okay, so my product is 6, so I'm going to write that down right there. My sum is that middle number 5. Okay, here's my product. It's the number that doesn't have a variable with it. It's a constant. My sum is this number right here, what's with the x. So this is what you ask yourself, and I would write this down right here. What 2 numbers multiply to get 6 and add together to get 5? What 2 numbers multiply to get 6 and add to get 5? So you kind of have to do some guess and check. So I always start with the products of 6. So 2 times 3. 2 times 3 is 6. And if I added those 2 together, I would get 5. So my numbers are 2 and 6. So all I do here is do x plus 2 and x plus 3. Okay? Now, I could check that if I wanted to. And the way that I would check that is to FOIL it. Okay, so I could do a check right here. Now, I want you to notice something right here. I have a positive 6. To get a positive product, you have to have 2 negatives or you have to have 2 positives. Okay, so I'm going to kind of write that down right here. The only way that you can get a positive product, okay, the only way you get a positive product is a positive number times a positive number, or a negative number times a negative number. So if your product is positive, you're looking for 2 numbers with the same sign. Okay, now let's look at the one just below it. Okay, x squared minus 9x plus 20. I still have a product that's positive. My product is 20. My sum is negative. Okay, so my product is right here and my sum is right here. So my product is positive and my sum is negative. To get a positive product, I have to have 2 of the same signed numbers. So 4 times 5 equals 20. But 4 plus 5 does not equal negative 9. Okay, but if I take negative 4 times negative 5, I do get positive 20. And negative 4 plus negative 5 does give me negative 9. So my numbers for this one are negative 4 and negative 5. Okay, and we are able to go from numbers to writing it in the binomial only because we have a 1 right here. When A is not 1, we have to have a different set of rules, and we'll talk about those in just a second. Okay, so let's look right here for our next one. I'm doing x squared plus 1x minus 6. So our product is going to be negative this time. I have a negative 6. And my sum is in what's in front of this x right here, and so I get a positive 1. Now, In order for me to get a negative sum, I'm sorry, not a negative sum. In order for me to get a negative product, I have to have a positive and a negative multiplied together. That's the only way. So if I have a product that's negative, I am looking for a number. One of your numbers is positive, and one of your numbers is negative. Okay? It has to be that way. It has to be that way. If it's not that way, then you've got the wrong numbers. To get a negative product, you've got to have one number positive and one number negative. Okay? So I'm going to look at 3 and 2 again. 3 and 2 again. So let's just say the 3 is negative and the 2 is positive. 2 times negative 3 does give me negative 6. But I also have to get positive 1. So 2 plus negative 3 doesn't give me positive 1. It gives me negative 1. So these numbers aren't right. So what I need to do is I need to check it if I switch the signs. So if I say 3 is positive and 2 is negative, it does work. 3 times negative 2 is negative 6. 3 plus negative 2 is positive 1. So there are my numbers. So I have x plus 3 and x minus 2. Okay, let's do the last one before we move into more complex. Okay, here I have x squared minus 2x minus 80. Negative 80 is my product. So that means I'm looking for numbers that have different signs because I have a negative product. My sum here is negative 2. Okay, so I'm looking at numbers with different signs that multiply together to give me negative 80 and add together to give me negative 2. So 10 and 8 give me 80. I'm going to make the 10 negative. I'm going to make the 8 positive. Multiply those together, I do get negative 80. Add those together and I do get negative 2. So my numbers are x minus 10 and x plus 8. Okay. Now we're going to move into factoring trinomials where I don't have a 1 right here. That's what we're looking at now. What happens when I don't have a 1 in front of the x squared? So let's look at some examples of those, what those look like. Okay. So this is standard form of all trinomials, ax squared plus bx plus c. Now, we were looking at problems that just had an a value of 1. So it was still this format. We just didn't have to worry about the a because our a value is 1. So we're doing this slightly different. What I want you to do is I want you to turn this into a grouping problem. So we're going to take our 3 terms and we're going to turn it into 4 terms. Now, in high school, I am sure that you were taught a lot of different ways to factor. I have found that this particular way involves the least guess and check. If you are comfortable with how you did it in high school using the box method or the X method, you're completely fine. It's fine to use that. But if you still haven't mastered factoring, I believe that this is the most straightforward and the least amount of guess and check. So we are going to take our trinomial and we're going to turn it into a grouping problem. And remember, for something to be a grouping problem, you have to have 4 terms. 4 terms. Now, our b value is still going to be our sum. Okay? So when we're identifying these, Our B values are still going to be our sum, but our product is going to be A times C. That's going to be our product. Now, we were doing that over here. It was just that our A was 1. Our A was 1. So 1 times 6 is 6. 1 times negative 6 is negative 6. Now, because our 1 isn't there, we've got a value other than 1. We have to multiply that to get our product. This is also called the AC method of factoring. The AC method of factoring. So to get this, I am going to take the 3 and I'm going to take the 4 and I'm going to multiply them together. 3 times 4. So 3 times 4 is 12. So the product that I'm going to be working with is 12. Okay. My sum is still this middle number. So my sum is 8. I don't have to multiply or do anything to find my sum. It's my B value, whatever's with that X, or in this situation, the T. So I still find two numbers, multiply together, give me 12, and added together, give me 8. I'm still doing that. Now, I was thinking times 4. 3 times 4 is 12. But when I try to add 3 plus 4, I don't get 8. So those aren't my numbers. So then I remembered that 6 times 2 gives me 12. 6 times 2. Now my product is positive, so I'm looking for either both negative or both positive. My sum is positive, so both of my numbers have to be positive. So 6 times 2 is 12. 6 plus 2 is 8. This is where students go wrong. This is where students mess up. Okay? They do the same thing that we did when our A value is 1, and they just want it to be x plus 6 and x plus 4. Okay? But x plus 6 and x plus 4, if we were to FOIL that, we would not get our original problem. So that doesn't work. This is how you have to do it. This is the AC method. What's different is our A. Right? We've got a number in front of that. Our A is not 1. So what we do is we split this middle term and we use the numbers that we found. So I've got 3t squared plus 6t plus 2t plus 4. Okay, so the numbers that we found that gives me a product of 12 and a sum of 8, I split it. 6t plus 2t is 8t. So I haven't changed the value. Okay, I've just split it. Now I can solve this the same way that I would solve a grouping problem. 3t comes out of both of these. So I'm left with t plus 2. Okay, so I just looked at these two right here. Now I'm going to look at these two. A 2 comes out of both of those. And I'm left with t plus 2. So my final answer here is 3t plus 2 times t plus 2. Now, if you wrote that in a different order, you're fine. If you did t plus 2 times 3t plus 2, that is absolutely correct. Okay. Now, let's do another one. I'm going to find my product. 2 times 15. My product is positive 30. Okay, my sum is this value right here. So it is negative 11. Now, I have a positive product, so that means I'm going to have a positive times a positive, or a negative times a negative. I have a negative sum, so that means I have to have two negatives. Okay, so I am looking for two numbers multiplied together, give me 30, added together, give me negative 11. So I start with negative 3 and negative 10. Negative 3 times negative 10 gives me positive 30. Negative 3 plus negative 10 does not give me negative 11. That doesn't work. Okay? But negative 6 times negative 5 does work. Negative 6 times negative 5 gives me positive 30. Negative 6 times negative 5 gives me negative 11. So it works. So I am splitting my middle term with the numbers that I found. So I have 2t squared minus 6t minus 5t plus 15. Okay, we're going to do the same thing that we would do if we were solving by grouping. What comes out of the first two? Okay, 2t comes out of the first two. So then I'm left with t minus 3. Okay, t minus 3. 2t times t gives me 2t squared. 2t times negative 3 gives me negative 6. T. Now, remember what I said, anytime that our third term is negative, I am factoring out a negative. Anytime. It works that way all the time. So because this is negative, I'm factoring out a negative 5 instead of just factoring out a 5. So then I'm left with t minus 3. Negative 5 times t gives me negative 5. Negative 5 times negative 3 gives me positive 15. So my answer here is 2t minus 5 and t minus 3. Okay. Let's do some with here we go. Here's another one with a negative sum. Okay, or a negative product, I'm sorry. So we are going to identify our sum and our product. So to get my product, I'm going to do 4 times negative 15. 4 times negative 15. That gives me a product of negative 60. Product of negative 60. My sum is this number right here, and that's negative 4. Okay. My numbers, I've got a negative sum, so I'm going to have a negative number and a positive number. Negative number and a positive number. 12 times 5 gives me 60. So if I made one of them negative, I would get negative 60, but negative 12 plus 5 does not give me negative 4. So that doesn't work. I could do negative 10 and positive 4. Negative 10 times, I'm not sure where I got 4 from. How about negative 10 and 6? Negative 10 and 6. Negative 10 times 6 gives me negative 60. Negative 10 plus 6 gives me negative 4. That works. So here are my numbers. 4x squared. I'm splitting that term. If you remember to split that term, you will remember how to do this. As long as you turn it into a grouping symbol, you're going to be okay. Right? A grouping problem, not a grouping symbol, a grouping problem. So what comes out of my first two? Be careful, because you might look at it and say, oh, a 4 comes out. The 4 does not come out. A 2 comes out and a 2x. So then I'm left with 2x minus 5. Okay. Here, notice this is not a negative, so I don't need to worry about taking a negative out. I'm just going to take whatever comes out of both numbers, and a 3 comes out of both numbers. So I've got 3 right here, and I'm left with 2x minus 5. 3 times 2x is 6x. 3 times negative 5 is negative 5. Okay, and then I'm done. I just have to rewrite it. So 2x plus 3 and 2x minus 5. Okay, now this is another special circumstance or a special product. Typically, students don't memorize this though. They just do it the same way that they do other problems. If you look closely, you will see that this is 4x squared, and that's a perfect square. 9 is a perfect square. This is 2 times the square root of each of these. Okay, so this is perfect. This is perfect. This is the square root of the first term times the square root of the last term times 2. But we already have to memorize the difference of perfect square. So I typically don't require students to memorize what this is called a perfect square trinomial, because if you do it the way that we've been taught to do the AC method, then you're going to find it anyway. So I'm going to find my product. My product is positive 36. So I'm looking for 2 numbers that are both positive or 2 numbers that are both negative. Okay, my sum is negative 12. Okay, so that means I am definitely looking for 2 numbers that are both negative. I always think about negative 9 and negative 4. So negative 9 and negative 4 multiplied together give me 36, but added together give me negative 13. So that doesn't work. Don't forget, though, that negative 6 times negative 6 gives you a product of 36. And negative 6 plus negative 6 gives you a sum of negative 12. So my numbers are both negative 6, and that's okay. They can be the same number. Okay, so I am splitting that middle term. Okay, now I'm going to solve by grouping. A 2x comes out of my first term and my second term. So I'm left with 2x minus 3. Okay, now this is negative, and anytime your third term is negative, you're going to be pulling a negative out. Negative 3 times 2x gives me negative 6x. Negative 3 times negative 3 gives me 9. Now, you still may not notice anything. And you may put your answer in and not notice anything. Hopefully at this point you will notice it, because here I've got 2x minus 3 times 2x minus 3. So what we have there is what we call a perfect square trinomial. Oops. The squared goes on the outside. Okay? So this is what we call a perfect square trinomial, but I encourage students to continue to solve this the same way they would always solve it. Continue to solve it the same way they would always solve it. Okay? Now, I'm almost done. So these are 2 things that sometimes we miss. These are 2 things that sometimes we miss. So here I've got 4x to the third minus 2x squared minus 6x. If you will notice, this is a trinomial, and so we might get in there and start doing 4 times negative 6 and trying to find out how to split this. But I want you to realize there's a 2 in every one of these, and there's an x in every one of these. So I can factor out a 2x. And when I factor out that 2x, it makes this easier to factor. Okay? It makes this easier to factor. So we want to be sure that we do that. Now, don't stop, because 2x squared minus x minus 3, that can be factored further. So I'm going to do it off to the side. I have a product of negative 6 and a sum of negative 1. Okay, so my numbers here are negative 3 and positive 2. So I have 2x squared minus 3x plus 2x minus 3. It looks like just an x will come out of that first two terms. And then at first glance, it looks like nothing will come out of 2x minus 3. But you can always factor a 1 out. Always factor a 1 out. So I have x plus 1 times 2x minus 3. So then I go back. Don't forget your GCF that you factored out. Don't forget that. Okay. So this is my final answer. Keep going. If you can keep going, keep going. Don't stop as soon as you factor out that GCF. Okay. This is similar. The next one that we're going to do is very similar. Okay. I want to factor using grouping. So I'm looking at the first two terms. An x squared can come out of both of those. So I'm left with 2x minus 5. Now, my second set, remember I've got that negative right there, so that means I'm pulling out a negative. I can pull out a negative 9. And then I'm left with 2x minus 5. So this factors to x squared minus 9 and 2x minus 5. And we are very tempted to stop. Okay? We want to stop, but we can't stop. I've got x squared minus 9, and that is a special product. So I can go further, and I can have x plus 3 times x minus 3, because that's a special difference of perfect squares. And then I have 2x minus 5. Okay, now we focused on factoring because factoring is typically the area that students get confused in. But I want to show you one more thing. You are about to start using factoring to simplify rationals. So we're multiplying rationals and then we're dividing rationals. Factor first. Once you factor, things all start canceling out. So factor each one of these trinomials first. Now, for division, I just want to remind you, you keep, you change, you flip. So you keep your first polynomial rational, change your division sign to multiplication, and then flip your second rational. Okay? Okay. You guys have a good week. Please remember, what you get in the lecture is not everything. It's just kind of your high points, the things that we want to make sure you get. So if you attend both lectures, you're still going to have some information that's not covered. Okay, don't hesitate to ask questions along the way and let your teacher know if you need anything. Have a good day.